Okay, so this is chapter 3, part 2 review sheet. Is the following relation a function? If it is the function one-to-one? Explain. So we're going to say yes, it's a function because for every input x, there is only one output, which are the y's. Only one, sometimes we say exactly one. Now, is it one-to-one? Well, no, if the y's are repeated, which they are here, it would not be one-to-one. So no, it is not one-to-one because there is an output, say 9, that corresponds to more than one input. And we could say 1 and 4. So 9 corresponds with 4, 9 also corresponds with 1. That means it's not one-to-one. For being a function, notice x's are not repeated. That means there's not the same x going to two different y values. So it's a function because every x corresponds with only one y. Now, f of g of x, that gets written f of g of x, which is putting the g of x into the f of x. So I get that. G of f of x is putting the f of x into the g of x, which means I get this. Okay, the domain of f of g of x, so that's the domain of this thing. As soon as I see square root, remember I'm going to set what's underneath the square root, greater than or equal to 0. X is then greater than or equal to -3. Here, again, square root. I'm going to set this greater than or equal to 0, which means x is greater than or equal to -2. Find the rule for f to the -1 of x. For each of the following, state the domain and range of both f of x and f to the -1 of x. Okay, so this is y equals this. When we do an inverse, we swap x and y, solve for y. So I can multiply both sides by y plus 4. So here, this is xy plus 4x equals 5. Then if we need to solve for y, we need to isolate the term with y. So xy equals -4x plus 5. Move this over. And then we are going to divide by x. And we're going to rewrite it f to the -1 of x. So that is our x to the -1 of x. Now, as far as domain, so domain of f of x, domain of f to the -1 of x. Then here we're going to have the range of f of x and range of f to the -1 of x. Okay, the domain of the original function, that's all reals except for -4, right? Can't have a 0 in the denominator. So that then becomes the range of the inverse. So the domain of the original is the range of the inverse. The domain of the inverse, well, now I have to look at the inverse. Numerator tells me all reals, denominator tells me can't be 0. So this is all reals except for 0, which means that's the range of the original. All reals except for 0. Okay. For the next one, again, swap x and y, solve for y. Remember, this is y. So when we swap x and y, it looks like that. Multiply both sides by y minus 2. So it's xy minus 2x equals y plus 3. Get everything with a y to one side. Factor out a y. So we got to get every term that has a y on one side, anything that does not have a y on the other side. That is so we can factor out a y, be able to isolate the y, and now solve for y. So I'm going to go right to saying f to the negative 1 of x is 2x plus 3 over x minus 1. Okay, so domain of f of x. So the domain of the original, that would be all reals except for 2. So domain of the original is the range of the inverse. So that means the range of the inverse would also be all reals except for 2. Domain of the inverse, this is the inverse, all reals except for 1. And then that is the range of the original f of x function. So domain of the original is the range of the inverse. The domain of the inverse is the range of the original. So that is part of our answer and all of this. Okay. This is the one a little bit tricky when we're doing domain and range. So again, this is y. Swap x and y. Solve for y. Equals y, which I'm going to make f to the negative 1 of x, right? So I'm solving for y. There's my inverse. Now, domain of f of x, we're going to have range of f of x, domain of the inverse, f to the negative 1 of x. So that again is f to the negative 1 of x, and then range of f to the negative 1 of x. Okay, domain of the original. Well, it's a square root. So I do the domain by setting it greater than or equal to 0. X is greater than or equal to negative 2. Now, sometimes what I do is I do it interval notation so that when I go to do the range of the inverse, I don't have to remember to switch from x is greater than or equal to negative 2 to y is greater than or equal to negative 2. So interval notation, then those just look the same. Otherwise, here I'd have to say x greater than or equal to negative 2. Here I'd have to say y greater than or equal to negative 2. Okay. Now, this is the only one where I can't look to the domain of this. The domain of this would be all reals. But that's not the range of this. If we think about it back on our day 2 of the last unit, this is a square root function that shifted left 2. So if you think about it, square root function shifted left 2 looks like this. So notice its range is 0 to infinity. So a square root function, if you haven't shifted it up or down, its range is 0 to infinity. So that is what the domain of the inverse is. Because here's the thing. if I graphed, so this is the f of x, its inverse is a reflection over the line y equals x. If I reflect this thing over y equals x, I only have that part. Well, actually probably looks a little more like this. But I only have that part of the parabola. I don't have the whole parabola. A parabola would not have an inverse because it doesn't pass the horizontal line test. So remember, for a function to have an inverse, it has to pass the horizontal line test. It has to be 1 to 1. So notice my domain here is just 0 to infinity. This graph's going 0 to infinity. So not the entire parabola. Okay, so it says prove inverses by showing f of g of x equals x and g of f of x equals x. Okay, f of g of x. Let's put the g of x into the f of x. So in place of x, I'm going to put this thing in here. So it's 3. Then I'm putting this in, and then plus 4. So I bring down the 3, I bring down the plus 4. In place of x, I'm putting this thing. Now, you have to show order of operations. So you have to know that the 3's cancel first, x minus 4 plus 4. Then those cancel, giving me x. You have to do that in 3 steps. Don't slash everything out, and then I don't know if you know order of operations. This is prove, show, justify, it'll sometimes say. You have to show that it's equal. G of f of x, so you have to show all steps, is put the f of x into the g of x. So I'm putting this thing into here. So that becomes 3x plus 4. That's going into there. Then I've got the minus 4, and then I've got the over 3. So now what you need to show me is that you know you simplify the numerator first, get 3x over 3, and then answer is x. F of g of x here. Okay, this gets a little tricky. Take the g of x, we're putting it into the f of x anywhere we see an x. So it's 2, this whole thing, then plus 1 over this whole thing plus 3. Okay, so this is a complex fraction. How do we solve a complex fraction? Well, we multiply through by the least common denominator. Oops, so this times this, we distribute. Then it's plus, oh, what am I doing? Plus, we got to distribute here, 1x minus 2. Here, those cancel, negative 3x plus 1, plus here I distribute 3x minus 6. So let's see. Those cancel. I get negative 5x on the top. These cancel. I get negative 5 on the bottom. The negative 5's cancel, and I'm just left with x. Now, g of f of x, we're going to take the f of x, put it into the g of x. So I start here, negative 3, and then I got to put this whole thing in for x. So 2x plus 1 over x plus 3 plus 1 over this whole thing goes in for x. So it's 2x plus 1 over x plus 3 minus 2. All right, so multiply everything by x plus 3. That cancels. We distribute the negative 3. Here we distribute the 1. Those cancel. Here we've got to be careful and distribute the negative 2. The nice part about that is if you probably missed that, you'd realize you did something wrong. Like, what did I just do here? I'm noticing. Oh, -3. There we go. So when I distribute here, -6x minus 3. Okay, because now those cancel. I get -5x. Those cancel. And then my -5's cancel, and I have x. Okay. Find the f and g functions such that h of x equals f of g of x. So this is kind of a working backwards. We want to find the f of x and the g of x function such that when you put g of x into f of x, you get the h of x function. So when we did this, I said, make your g of x the thing inside the parenthesis. And then the f of x, you could just replace this with x. Why would you do that? Well, because then doing f of g of x means to take this g of x and put it in for x in the f of x function. So you're going to put this in here, and you're going to get the h of x function that you started with. So you're going to put that in, get that. So as long as it works, that lets you know that you did it right. So answers can vary here. Okay, so here, g of x, I'm going to make the thing underneath the radical. That way f of x is just going to be radical x minus 2. So I'm going to put the g of x into the f of x. I do get the h of x. Then I know I did it right. And finally, for this one, I'd make the g of x the thing inside the absolute value bars. And then that could then just be absolute value of x plus 2. When I put this into there, I get the h of x function. All right, so now some stuff with writing equations of lines. Okay, they want to know what's the slope of this line. Well, I've got to get it into y equals mx plus b form. All right, so this is 1/2 x minus 5/4. So 2/4, I'm saying, is 1/2. And then that's -5/4. So for what's the slope of this line? 1/2. What's the y-intercept? That's the -5/4. Because this is the same line as here. Slope of -5, y-intercept of 3. So I'm going to use my y equals mx plus b form because they're giving me the m and the b. So this would be y equals -5x plus 3. Now, when they give me a point and a slope, I'm going to use point slope form, which remember is y minus the y coordinate equals m parenthesis x minus the x coordinate. So I would then write that y plus 8 equals 2 parenthesis x minus 4. Minus, minus, I'm going to write this plus. For 16, we do not have the slope. Can't write an equation of a line without a slope. So I got to figure out the slope, y minus the y. I always subtract so I don't get a negative. So I go 5 minus -2. Then I have to go -1 minus 6. So I get 7 over -7, which is a -1 slope. So your answer, you could either choose this point or this point. So your answer could either be y minus 5 equals the -1 and then x minus the x coordinate. So that would be, so minus -1 again is a +1. Or I'm going to come here and say, or someone else might say, well, I want to use this line, or this, point. So they're going to go y minus the y coordinate, minus -2 is +2. equals m, which is negative 1, and then x minus the x coordinate. So that could also be an answer. All right, passes through this point parallel to this line. Parallel to this line means I need to know the slope of this line. So let's see. 4y equals, I'm going to bring this over, divide by 4. So slope of the line parallel is negative 3/4. So the slope of this line is negative 3/4. So the slope of the line parallel to this line would also have to have negative 3/4. And then we want it passing through this point. So I'm going to go y minus the y equals m parenthesis x minus the x. Minus negative 2 is why I'm writing plus 2. Perpendicular to this line, passing through this point, perpendicular would have a negative reciprocal slope. So move the 4x over, the 9 over. So the slope here is negative 4, which means the slope of the line perpendicular to it would be positive 1/4. Flip and negate. So then it's y minus the y equals m parenthesis x minus the x. Minus negative 1 is why those are plus 1. Parallel to the line y equals negative 1, if you need to sketch that, you can certainly do that. Here's the line y equals negative 1. All right, this is the x, this is the y coordinate. So this is y equals negative 1. And passing through the point 8, 3. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So if it's got to be parallel, passing through that point, it means it'd have to be a y equals 3 line. Now, you can know parallel to a y equals line would be another y equals line, and the y is 3. So that's another way. Perpendicular to the x-axis. Okay, well, let's think about this. Here's the x-axis, here's the y-axis. If it's going to be perpendicular to the x-axis, that means it's going to be a vertical line. We should already know a vertical line is x equals. What does x equal? Well, it equals 2. Okay, let's say you couldn't, kind of go right to that. Just plot this point. 1, 2, negative 1, 2, 3, 4, 5, 6, 7. It's right here. So if I need the line to be perpendicular to the x-axis, this is the line x equals 2. Every point on this line has an x value of 2. Okay, so that is it for the review sheet for Unit 3, Part 2.